Hi, everybody. My name is Professor Mustafa El Miloudi. I'm going to be your instructor for this class, 1436. So we're going to go ahead and get started. So let's go very quick over the syllabus, see if you have any questions. So open the syllabus very quick. All right, so the class is online. All the materials are online. This is the book starting out with C++ from control structures to object oriented. Okay. So all of this information, please take time to go over them. If you have any questions, let me know. This is the breakdown, the grade breakdown. As you can see, projects. We have 2 projects, 20%, quizzes, 20%, programs like programming assignments, so 20%, and exams, midterm and final exam, 30%. Participation discussion is 10%. And this is basically the calendar, as you can see. Now, so for your convenience, all the due dates, all the assignments that are due or quizzes, they are posted on top in Tidwell. So just for your convenience. So today we're going to be starting with chapter 1. It's about introduction to computer science. Actually, yes. So we'll be talking about the basics and introduction to software engineering programming languages. So this is all the due date. This is the topics we're going to be covering. So if you have any questions or any concerns, please let me know. So for the IDE or the coding platform we're going to be using, it's called Visual Studio, but feel free to use any other program that you feel comfortable with. So I posted like a couple of videos that show step-by-step how to install the program. So just follow the steps. Let me go over. If you go to contents, so this is the video I'm talking about. So to download Visual Studio 22 community version, so just click on this link. It will take you step by step. You can't miss it. Okay. And also there is another video that shows you how to start your first program in Visual Studio. So as you can see, so please make sure you take time to watch the video, and just if you still have questions, please let me know. I can help you with any issues that you may have. So for the first chapter, make sure first that you, I know some of you already did this part, introduce yourself, discussion, make sure you answer the question and reply to at least 2 classmates. And also there is a video that you need to watch. It's called What is Computer Science All About? Because the first video quiz 1, which is participation grade, you just have to watch the video, and I think we have a few questions, I think 5 questions about this video. So the video basically talks about the different areas in computer science, because a lot of people, they confuse computer science and programming. They think programming is computer science is programming. This is totally not true. Computer science is the huge field. There are a lot of areas within the computer science umbrella. So this video talks about this field, and also it gives you a good idea about what options you have. So especially like if you are looking, to what kind of programs are available, to see which one you feel comfortable with, which one you are interested in, which one you think you can choose. So that's a very good video that kind of summarizes everything that you need to know about the field of computer science. And then, of course, you can answer the question based on that video. All right. So let's start with the chapter 1. Chapter 1 basically is very simple, straightforward. It's about the basics of computer and then how to start a new program. So let's start with the basics of computer, and then I will show you how to start your first project, C++ project, using Visual Studio. Of course, I'm assuming that you already went through the process of downloading Visual Studio. As I said, there is a video that shows you step by step how to do that. All right, so now let's start with chapter 1. All right, so chapter 1, as I said, it's basically like the main components of the computer. What is the computer system made of? So like certain terms like computer, what is a computer? A long time ago, computer used to refer to a person. Like when you say accountant or you say a plumber. So computer used to refer to someone who does computation. Of course, then it changed to refer to a machine now. So a computer is a programmable machine designed to follow instructions. And the program are nothing but instructions in computer memory to make it do something. So there is the big thing, which is software. Software is made of programs, and the programs are made of instructions. So that's basically where it's coming from. And the programmer is the person who writes instructions. Of course, you have to have a programmer to make the computer perform tasks, because the computer just follows the instructions that the programmer makes. So without programmers, there are no programs. Now I'll talk about the computer system. I'll talk about the components. So let's start with the very simplistic definition of a computer system. Of course, there is more to that, but let's just, look at the simplistic, simple definition. So the simplistic definition of computer is that the computers or computer system is made of the following components. You have the central processing unit. You call it CPU, which is basically the brain of the computer. That's where the arithmetic or logical operations are taking place. Main memory, that's where you save your data on your programs. Secondary memory. So we have the main memory. It's kind of kind of temporary. So that we call it RAM, random access memory. As long as there is a power in the computer, the data are saved. But once the power is out, then all the information is gone. So the main memory or RAM are just for temporary saving, for temporary, not for long term. That's why we have to have secondary memory, like the hard disk, like flash drive, like any external memory storage we have. And then we have input devices and output devices. Input devices basically are the devices that we use to get the information inside the computer. And the output devices is the opposite, like the devices that we use to get the information out of the computer. We're gonna have some examples, like input devices, for example, a keyboard. What do we use the keyboard for? It's to type information or data so the program can process it, the CPU can process it. So we call it input device, like the mouse also, like the scanner. All of these, we use them to get the information, basically to feed the computer with data. And output devices, after processing this data, then they will come out from the computer, either in the monitor, so you can see it, so you can visualize it, or to print it like printer, or like speaker, so you can hear the voice. So these are output devices. So this is our examples of these components. So let's start with the central processing unit. So we said that the CPU is basically the brain of the computer, and it's made of two things, of two parts. There is the arithmetic and logic unit. That's where the computation, the calculation is taking place. So for example, if you want the computer to add two numbers, so this is where the addition takes place, or multiplication or division, or you compare two things, which one is bigger, it happens here. Now the control unit is the the parts of the computer or the part of the CPU that make sure that all these instructions are in order. You can call it the police of the CPU, to making sure that the traffic is organized in a smooth fashion. What is instruction one? Like, for example, when you add two numbers, okay, what do we need? Do we have the first number? Okay, we need to find the location or the address of the first number. What is the second number? You find the location in memory of the second number. Now, what operation are we talking about? Plus, and then you perform the addition. So control unit is basically making sure that everything is in order, making sure the traffic goes smoothly. So this is basically a diagram or that summarizes all of this. So there's instructions coming out from outside. It could be keyboard, it could be mouse, it could be scanner. And then all this processing happens here inside the CPU. And finally, you get the result either as from the printer, from the monitor, or any other way. So we talked about the main memory. We said that the main memory is volatile. Volatile means it's not permanent. That means as long as there is a power, data are there. Once you the power is out, then it basically disappears unless you save it in a hard disk or external memory storage. So RAM. And by the way, the memory is divided into two. There is a RAM, the one that we talked about, and there is a ROM. It's read-only memory. ROM is a data that you can never erase. It is made by the manufacturer of the computer. So whoever manufactured the computer, he will save some information in a place called ROM. It will never be erased, whether there is a power or not. It will always be saved in there. Let's use the analogy of a human being, for example. There are certain things that you will never forget, right? For example, how to eat, how to walk, how to speak, because it's made the first time and then it stays there. But there are other parts that you may forget. Like if I ask you, okay, what did you eat like 2 weeks ago? You may not remember. Or if I ask you something about, information that we just talked about an hour ago, no, yesterday, you may forget or you may remember some of them. So that's the difference between RAM and ROM. RAM is something that is saved temporarily. ROM, it can never be erased. It is made by the manufacturer when the computer was built, and then it stays there forever. You don't even have access to it to begin with. And then memory, as you can see right here, it's made of storage places called bytes. Bytes, or the smallest piece of memory is called bits. You can call it as like one little box or smallest storage that either on or off, either the light is on or off, okay? And then 8 of them, we call them bytes. That's like, for example, to save like a letter, like A, when you tap the letter A, it will be saved in this 8 bits or bytes. And then you put B, that's another byte, and so on. Addresses, everything has an address. That's what makes the computer find the information. It has to be saved in addresses. So each byte in memory has a specific address that allows the computer to retrieve it when you need that piece of information. So this is an example of that, as you can see right here. So let's say when I tap 149, it has to be saved somewhere. So here, the address, for example, is 16, okay? 72 is an address 23 and so on. So everything has to be has to have an address so we can easily find it when you want to retrieve it. Secondary storage.
Like a pointer, right?
I'm sorry?
Like a pointer, right?
Yes, pointer is an example of that. Yeah, it's an example of that. Yes.
Okay.
Oh, thank you, Hector. As I said, secondary storage is for permanent storage, whether it's inside the computer like hard disk or outside like flash drive. We have magnetic, we have optical. We have a variety of ways to save your data and programs for permanent use. Input devices, we talked about that. So we said that any device that we use to get the information inside. Now, let's talk about software. So we said software is a set of programs, and programs are set of instructions. So we have two types of software. There is a system software. So that's the main software. Like when you buy the computer for the first time, all what you have is software. System software like Windows or Linux. Without that software, you cannot even, there's nothing you can do with the computer. Why? Because you need something, a software, a program that will be like an intermediation between a human being and the machine, because there are two different languages. There's the human language and there's a machine language. So it's very difficult to communicate unless you have something or someone who can translate from one. Just like when you speak to someone who speaks a different language, there is no communication going on unless you find someone who can translate from English to Spanish or another language. Okay, so the system software, like say Windows, like Linux, that's what they do. That's the operating system. Now there is another type of software which is called application software. Now application software is a software that we use it only for a specific task. There is a specific reason for that application or for that software. Like for example, if I say Microsoft Word, when do we use Microsoft Word? We use it for a specific reason, for word processing only. Now, if you want to make a presentation, Microsoft Word may not be the best software for you. You need to go, for example, to PowerPoint. If you have some calculations to be made, maybe you're going to go to Excel. Or you have database management system, maybe you should go to Access. I'm just giving you examples. Or Notepad for text file. Okay, so this we call them application software because they serve a specific purpose or task. Program, now let's get to programming languages. So we said that the program is a set of instructions that the computer will follow step by step using like an algorithm, like step-by-step instructions. So what is algorithm, by the way? So algorithm is, it's like when you tell someone, like let's say somebody came to this city, is new to the city, doesn't know anything about downtown. And you need to give them instructions, like very specific, well-defined steps, how to get to downtown. It's not enough to tell him like vaguely, okay, just, take the I-10, okay, make a right. No, you have to be very, very accurate. Like since from the starting point, what street, what highway, which exit to take, how long, or how. So you have to be the more specific, the more accurate, the more efficient and effective the algorithm is. So our algorithm is a step-by-step, well-defined steps to perform a specific task. Like here, this is an example. So this program will basically calculate the pay. So before you do that, first step, okay, get the information from the user, save it in a variable, do the calculation, okay, the processing, and then display the information. So that's an example of algorithm. Now we talked about the languages, right? We said there is a human language, and there is, because we are trying to communicate with the computer. The problem is the computer has its own language. It's called the machine language. Basically, it's just a bunch of zeros and one. Now, for a human being, it's very difficult to understand that language. I mean, you can, but it's only for few people who can, who can understand it with ease. For us, that's why. So we came up with languages that are somewhere in the middle. It will be between the human language and the machine language. The closer we get to the human language, we call it higher level. That means closer to the human language. When you go down, it's called lower level. Like for example, assembly language is closer to the machine language. Okay, And then high-level language, it's closer to the human language. So machine language, as you can see, it's an example. That's a bunch of zeros and one. It may mean something, like, for example, it may be A plus B, for example, here, okay? So, of course, if we use this language, it's going to be very difficult to make a program, okay? That's why we came up with, or the, programmers, and they came up with different languages that make it easier to make a program, okay? So we said low level, higher level. So the most popular higher level language is the one we're going to be learning about, which is C++, Java, C#. All of these are basic. Is the first language I learned. It was in 90, I remember. That was my first language I learned, basic. And then I learned COBOL, and then Pascal, and then Visual Basic in Texas A&M. And then, after that, Java, Python, C++, and PHP and other languages, JavaScript. All right, so this is basically the steps you go through until you get an executable file, okay? First one, you start by typing a program like in a text editor or any IDE program, and then you run. That's the program we type. And then preprocessor is basically certain files that C++ provide you with to help you, okay? It's like you don't have to worry about that part. Java, the C++ will help you with that. It's called preprocessor. So anything that you get that C++ provide you with to use, but you don't have to create it from scratch, it's called preprocessor. And then after you finish your program, you compile it, make sure that there are no errors, and then it will be translated into machine language. So compilation or compiler, the job, the function of the compiler is to translate that program, which is a high-level language, into machine language. Now, by itself, it has to come with a linker. Linker basically is, it's going to link the program that you compiled with basically hard with specific code to the machine instructions together, and then produce an executable file. So these steps, that's when you get an executable file. So you have to go through these steps. So you start with the source code, we call it source code, and then preprocessor, you compile, you link it, and then you convert it to an executable file. So this is basically the summary of this. Now, of course, you don't have to worry that much about this because, as I said, if you want to go specific about the steps, then that's another class. Like, for example, you can take a class called computer organization and architecture if you want to go too deep into this. So for us in this class, we just have to learn the basics, how the computer works, and then we focus on the higher level language. IDE stands for Integrated Development Environment, which is a fancy word for a coding platform, like a place where you use, like, for example, we use Visual Studio. So for us, other people may use Eclipse. Other people, they may use a variety of JGrasp. You can use it also for C++. So there are a lot of IDE or coding platform that we can use. So for this class, so we are using Microsoft Visual Studio. So this is an example of program. So we're gonna have, if we have time, we can make a program very simple like this to show you how you create your first project. So what is the program made of? Any program is made of the following. Some keyword. Keyword basically are certain terms that they have a special meaning for C++. Okay? Keyword, sometimes they call them reserved word. That means you cannot use them because they have a special meaning. Now, programmer defined, you can call them variables. So variables, you can call them anything you want. As long as you don't violate a few rules, you can name your variables anything. When I say identifier, it could be variable name or class name or file name. They follow the same rules. Operators like plus, minus, higher than, less than. So all the mathematical, thing that we use, it's under operator. Punctuation. So there are sometimes we have to use comma to separate the variable, semicolon to end every single statement. So semicolon is the way we end the statement so we can start a new one. Syntax, basically, you can call it the grammar of our language. That's an example. As you can see, all what we talked about is in here. So for example, an example of keyword is double. Double means anything that is decimal, that has point something, okay? Int, int, we're gonna talk about this in detail in chapter 2. So int is only integer. Char means character, and so on. So here you declared your variables, hours. So this is a programmer, variable, rate, pay. So we put comma because all these three variables, they share the same data type, which is double. Cout is just for printing. So when you put cout, so whatever is in there, it's going to show in the outputs. CIN is when you get the information from the user. Like, for example, when you ask, how many hours did you work? Now, user will type something, hopefully a number. So when you put CIN, that number will be scanned and saved in a variable called hours. And then you do the same thing for rate, and then you calculate by multiplying hours by rate, and then you save the answer in another variable called pay, and then you display the answer. So cout is for displaying any information. CIN is to ask for information, for inputs. For example, if I ask you, okay, what is the sum of two numbers? So you're going to ask me, okay, give me these two numbers. So that's what CIN does. So CIN will get you, it's like a prompt and ask for information, for input, so we can save it in a variable and then do whatever calculation needs to be done, and then we process it and then we display the outputs. So the keyword, we talked about this, double, we're going to be learning a lot of keyword that we're going to be using, you're going to be familiar with them. So here, this is an example. Now, for the programmer defined, we said that this is something that the user will choose, but there are some rules. I think there are 3 or 4 rules. You can name your variables or your file anything you want, as long as you don't violate 4 rules. Don't start with the number. Don't start with the number. For example, if I want to name my variable grade, don't call it 5, number 5 grade. Don't start with the digits. That's the first rule. Second one, don't have space in the middle. So for example, if we have a variable called grade average, don't put grade space average because you are creating confusion. So the computer may think that you are creating 2 variables, not 1. So that's a problem. So that's why it does not allow any space. So that's the second rule. The third rule, the only special character you can use are underscore. Underscore is the only one. You cannot use question mark. You cannot use exclamation mark. You cannot use dot. You cannot use comma. I'm talking about the variable. It should be a combination of letters, basically characters, but the only characters, it could be like digits or alphabetic, but don't start with the number. But the special characters, only underscore is allowed. And finally, the fourth rule, you should not name it a keyword. Like, for example, you cannot call it double. Double is a keyword. You cannot call it return because it means something. Okay? All right, now let's talk about the operators. You should have no problem with this because you did this in math. Because the good news is whatever you learned in math is applicable in computer science, including PEMDAS, the order of operation. In computer science, they respect the order of operations. So the parentheses come first, and then after parentheses you have exponent, and then division, multiplication, then addition, and subtraction is the last one. So in computer science we follow the same order of operation. Okay, so as you can see, this symbol, we use the less than, two of them. If it's pointing to the left, so we are printing something. If it's pointing to the right, CIN, then that means we are getting information from the user. Whatever the user will type, it will be saved in that variable that you can see hours. We're going to have an example, so it will make more sense. All right, and then of course the punctuation, the most common one is comma to separate things, and semicolon to end the statement. Semicolon has to be at the end. That's how the program, that's how C++ knows that you are ending, you are terminating a statement, and you are about to start a new one. All right, syntax basically is the grammar. Make sure, it's like when you are typing documents in English, you want to make sure that grammatically everything is fine, there's no errors and stuff like that. So it's the same thing for our. Now for variables, we'll talk about this in detail in chapter 2, but let's start with the definition. What is a variable? Now in math, it's almost the same thing, but we're going to add a few things to the definition that you are familiar with in math. In math, variable is anything that changes value. That's why they call it variable. That means it varies, it changes. When you put x equal 5, for example, that means it could be also 2 or 3. So it changes, okay? A variable is a named storage. But in computer science, in addition to the fact that it changes value, it's like a storage, which means if I have a plan to use a variable to save information, so we use variable to save information there. Okay. Now, when you declare a variable of any type, it's like you are telling the computer to allocate space or memory for that variable. So the next time you you want that variable to be used, then you can it will be easy to retrieve it. Okay. Now for the high level language, you just have to remember the name of the variable. You don't have to remember the address, because if you are asked to remember the address, it will be so complicated. But for us, as long as you know the name of the variable, that's it. That's all what you need to know. So this is an example. So let's say I want to calculate how much you get paid per week. So what information, what variable do I need? I need a variable called hours, because I want to know how many hours I'm going to be working, right? So I need that variable. Now, how many hours, what kind of data? Most likely it's going to be integer, right? 5 hours, 6 hours, 7 hours. Okay, so the type would be integer. So we're going to use the data type int. That means this number has no decimal. Now, what else? I want to know how much I'm going to get paid per hour. That's the rate. But the rate, is it going to be integer only? Very unlikely, because when you get paid, some people, they get, 15.75, 25, 50. So most likely it's going to be a decimal. That's why we're going to choose the variable or the data type double. Double means it accepts a decimal point, like point something. And then finally, now once I know the hours, I know the rates, now I need to calculate how much per week. So I need another variable to save the weekly pay. So that's why you have pay. And most likely it's going to be a decimal. Why? Because if you multiply a decimal by integer, most likely you're going to get a decimal or double. So we need 3 variables to calculate a weekly pay. All right. So as you can see right here, now even though hours is integer, but you can make it a double, because integer is part of the double. Any integer is double, but not every double is the integer. So here, as you can see this example, we declare all of them as double, like as decimal variables. All right. So this is how you declare them. As I said, we're going to have an example about this. So any program has to go through these 3 steps. And then we talked about this a few slides ago. We said the first thing, you gather the inputs, you gather information. Using the same example, you have to ask about how many hours the person or the employee works, how much he gets paid per hour. These are necessary information. So that's the first step. The second step, you do the calculation. So you multiply the hours by the rate, and then you save the answer in another variable called pay. This is called processing, process the input there. And finally, it's time to display the information. So we display the result as output. So this is the 3 steps that every program goes through. Okay, that's another example. So that's pretty much about chapter 1. Now let's have an example here. Let's end with an example. So what I'm going to do is I'm going to open Visual Studio. So I'm going to open Visual Studio, and then I'm going to share my screen. So Visual Studio. So I'm using, of course, Community because it's free. Okay. Okay, now I stopped here. Let me share my Visual Studio. Okay, can you guys see my Visual Studio? Hector, can you see it?
Yes, I can see it. I can see
Okay,
it.
perfect. So once you open Visual Studio 22, make sure you click Create New Project. So I'm going to click Create New Project. And then I'm going to choose Empty Project. Empty Project. And then you click Next. And then I'm going to choose where I'm going to save my work. So let's say I'm going to go to desktop, for example, and then I'm going to create a folder. I'm going to call it C++ programming assignment, for example. You can call it anything you want. So this way, it's easy for me to find my files. I don't have to keep looking. So I'm going to double click. So right now, see that? So now it is, and then I'm going to select the folder. See that? You can see here C++ desktop, and this is the folder that I'm saving my stuff in. Now you can call it, I'm going to call it my first program. Okay. Now remember, this empty project, this is only the project that is empty. There's nothing inside. So I'm going to click create. That's going to take me to the next page. Guys, pay attention to this because this is important. Okay. So now it's empty. That means there's nothing. What's the next step? Let me see here. It's asking me to sign in. I think that's a community. Okay. Okay. So now once I do that, now you go to source files. Can you see source files? And then you right click on it. And then you go to add item, new item. Because remember, the project is empty. Now you're going to create the C++. Can you see it ends with CPP? Make sure it ends with CPP. And then I'm going to call it my first program. And then you click add. So that's going to open my first program. So it's going to take a little while. Can you see that? So let's start with the first one. The first one, you start with the hashtag and then you put include. You always start with this. IO stream. Every program you're gonna have this. These two lines, you always gonna have to using namespace std. Okay, so these two lines always hashtag include iostream. So iostream is basically for cout and cin. So you need this using namespace. Okay, and then after that you're gonna put int main empty parentheses, and then you open and then you close. And then the last one should be return 0. So every single program you have to have this. Minimum is this. Now, there's nothing now. There's no code, but you have to have this. It's like this is basically the foundation of your program. All right. So now let's type something. I'm going to put here cout. Cout means to display something. This is basically something called comments. Comment is not part of the code. It's just to explain to yourself, to other people, what you are doing in the program. For example, here, I'm going to put a comment that this is a program that calculates the weekly pay. So that's gonna help people understand what you are doing. So the first thing, look, cout, I'm going to put statements. Enter the, what do we call it, the hours worked, how many hours. And then and L means finish and start new line. It's like hit the enter key, basically. Now, I'm not finished yet, but let me run the program and see what I have. Can you see like there is a play button here? Okay, so I'm going to click on it. So that's going to run the program. See that? So whatever I tapped here is going to show. Sometimes it's 6. It takes a while. Can you guys see it? Enter the hours work. Did you guys see it?
Yeah, I can see it.
Okay, perfect. Okay, so all what I did is type or print these statements. Okay, now we said that we need to have variables. So let's declare this variable. So let's declare hours as integer. And then everything else, which is the rates, or let's call it pay rate. See, I didn't leave any space. And then the weekly pay. Because you cannot use a variable unless you declare it. Declare it means tell what type. Okay, what type? So hours is basically integer. That means something that I cannot put 0.5 or 0.7. Double means it allows decimal, point something. All right, now what I'm going to do, I'm going to put CIN. Since I ask what hours, I'm going to put CIN hours. What does CIN hours means? That means when you ask the question, what is the number of hours, you're going to type something. So the program will scan whatever you type, the number, and then it will save it in variable called hours. Okay, so it is saved. It's already saved. It's like a box, and you are saving that information. Now we're going to ask the second question, which is how much you get paid. How much you get paid per hour. Again, I'm going to put and L. So what is and L? And L means finish that line and start new line. There's an alternative, which is, if you don't want to put that, you can just put \n. They mean the same thing. So \n means start new line. See that? So the first, this one and this is the same. But \n, it has to be between double quotes at the end of the closing quotation. Now, whatever we did with the hours, we're going to do it with pay rate. So we're going to put CIN. Remember, CIN to get the input. Cout is to display. So I'm going to put the other one, pay rates. Pay rates. Okay, now I have the information I need. I just do the calculation. So the calculation is, okay, perform, so I'm going to make a comment, perform the calculation. And then so I'm going to multiply the hours by the pay rate and save the information where, in which variable? Weekly pay. So I'm going to put weekly pay equals the whatever the hours. Remember, we saved some value in there. That's why we put CIN. That means we put the information in there. Whatever the user type, it is saved by the program. And then I'm going to multiply by pay rates. Okay. So now the answer is in weekly pay. The only thing missing is you have to display. If you don't display, you're not going to see it. So see out, and then I'm going to put the weekly pay is, and then I'm going to put these two symbols just so we can separate the text from the variable. You cannot put them together. I cannot put it like this. Weekly pay. I can't. I'm going to have a problem here. You have to separate them. You have to put this symbol and then you put your variable. Weekly pay. Oh, sorry. Weekly pay. Okay. See, P should be capitalized. Remember, it's case sensitive. You have to display. Okay, now we are done. This program is complete. Now let's run the program and see how it works. So I'm going to run the program and I'm going to wait. The program, C++ will go one line at a time. Look, it's not going to show me everything. No, it's going to ask me the first and then wait for your answer. How many hours? Let's say 35. And then it's going to wait until you hit the enter key. When you hit the enter key, it's going to ask you the second question. How much you get paid per hour? Let's say 42, or you can put 42.75. Remember, because we said double, we are allowed to add 0.75. Now, once I hit the enter key, what's going to happen is going to multiply the two, save them in the variable weekly pay, and display the information. Look what happened. See that? The weekly pay is, look, 1496.25. Let's say I want to add the dollar sign. I can add the dollar sign. What I'm going to do is I'm going to put it right here, look, because it has to be in the text. You cannot put it outside because anything between double quotes, the program will copy it and paste it exactly the way it is. So now let's run the program again. See that? Enter the hours. So I'm going to put 30. 30. Hit the enter key, the second question, and then let's say, okay, 45.50. Hit the enter key. Look, the weekly pay is, look at the dollar sign, 1365. Okay, so that's basically, so as you can see, it's very simple, step by step. Make sure you start with this, the hashtag include IOStream using namespace std. And then you put int main, close the parentheses, and then the opening brace and the closing brace. That means anything, the code should be between these two braces, the opening and the closing. And the return 0 should be the last one. And as you can see, you can put comments anywhere you want. As long as you start with 2 forward slashes, the whole thing is a comment, the whole line. You declare your variables. Why? Because you're going to ask for information. You have to save them. Because if you don't save them, then the program does not even recognize them. So you cannot, the computer cannot do anything unless you have your data saved in storage places called variable. And then we'll talk in detail about the, let's say I'm going to add the name, okay? So what is the name? It's a data type, another one called string. String is anything that has basically characters like an alphabet. I'm going to put name. Okay. So let's say we're going to ask about the name. So let's say here I'm going to put say out, enter your name and L. Now again, I'm going to put CIN and then I'm gonna put my name. Then at the end, the weekly pay is this, and then I'm gonna put thank you so much, and then whatever the name is. So I'm gonna put see out. Thank you. And then I'm gonna put name. That means whatever your name is gonna show right here. So let's run the program and see what's going to happen. So again, it's gonna start with enter your name. See that? So let's say John. Enter the hours worked, 35. How much you get paid per hour? 25.75. See that? The weekly pay is 901.25. Thank you, John. It's simple. All right. Any questions about this program?
I can't. I don't see the terminal.
You can see the terminal. Hold on.
Yeah.
Because I
I
asked you earlier.
I just realized.
I asked
Yeah,
you earlier.
I saw the.
Okay,
like
let
I
me
can see
start.
the.
Okay, let me stop, and then I will share my.
Yeah, like I can see the entirety of the screen.
No,
But
maybe the
I don't
terminal
really
is
see
a
the.
separate. Can you see it now?
Yes,
Oh,
right there. It's a separate screen.
so yeah, enter your name. I'm gonna put here David. Enter the hours worked, 35. Enter how much you get paid per hour, 42.90. See, the weekly pay is 1501.50. Thank you, David. See that? So of course, don't worry about this because we'll talk in detail about this in chapter 2. I'm just showing you how to start new program. But don't worry about if something does not make sense. We haven't even started this because this is not part of chapter 1. I just want to show you how you make a program that it is not complicated. It's just like step by step, one line at a time. In chapter 2, we'll talk in detail about the variables, when to use int, when to use double, when to use string, and stuff like that. And then how do you display, how do you get the information on stuff like that. But I think this program is not that hard to understand. But even if something does not make sense, just don't panic, don't freak. We will talk about this in chapter 2. Any questions before we end this? Any questions? I will post this video in Tidwell, so maybe you can watch it and then take your time. Maybe it will, it will make sense to you once you take your time and then you watch it, maybe for the second time. Okay. Any questions?
Nope.
All right. Thank you so much, Hector, for being here. So
yeah, no problem.
we're gonna end the meeting. So please let me know if you have any questions. So we will meet also next week, always the same time. If you have questions, if you have concern, or if you want to something does not make sense to you, you are more than welcome to attend our meeting. We always have it at the same time, Monday at 8 o'clock. Okay.
All right. Awesome. Thank you.
All right. Thank you.
Take care.